Welcome to the AI Research Roundup. I'm Alex. Today, we are looking at a paper from the Hugging Face trending list, published on December 24th, 2025. So, just yesterday. This paper introduces DreaMontage, a framework for arbitrary frame-guided one-shot video generation that stays temporally coherent and can scale to long durations with a memory-efficient, segment-wise, autoregressive inference strategy. The paper is titled DreaMontage, Arbitrary Frame-Guided One-Shot Video Generation. And as we go through it, the way it combines lightweight conditioning, curated fine-tuning, and preference optimization makes the one-shot effect feel surprisingly cinematic. Figure 1 explains the core promise, which is turning scattered visual anchors into one continuous long-take video. The full graphic lays out a timeline where prompts and user-provided keyframes or short clips get pinned to exact times, so the model has concrete targets to hit. The callouts at about 1 second, 7 to 10 seconds, and 16 seconds show different anchor types, while the film strip along the bottom suggests smooth in-between frames all the way to about 60 seconds. Figure 2 explains how DreaMontage turns user anchors into a long-take video because it lays out both training and inference in one place. The full diagram splits into a left training pipeline and a right inference pipeline. The left side stacks 3 stages: interim cont adaptation, visual expression supervised fine-tuning, and tailored differentiable prompt optimization, so the model learns control, style, and smoother motion. The right side shows reference images or videos and prompts going through a video variational autoencoder and text encoder into base DIT and super resolution DIT for autoregressive long generation, which keeps memory use manageable. Figure 3 shows why arbitrary frame control breaks if training treats a condition frame like a precise timestamp. The key issue is that a causal video variational autoencoder compresses time, so one latent can mix information from multiple frames. In panel A, the condition at frame 2 gets mapped into a blended latent, which creates a temporal mismatch when it is concatenated into the diffusion transformer. In panel B, the fix re-encodes the single condition frame and re-samples the rest, so training matches inference behavior. Figure 5 explains how the method teaches the generator to avoid 2 specific video failures: abrupt cuts and unrealistic subject motion. The full figure lays out 2 pair-making pipelines, because differentiable prompt optimization needs a good versus bad example for the same condition. Pipeline A uses a trained vision language model discriminator to pick the best and worst videos from different seeds. Pipeline B relies on human annotation, since vision language models miss subtle motion and plausibility, and both feed tailored differentiable prompt optimization training. Figure 7 means the method tends to win human preferences against strong baselines, especially on motion and prompt following. The green, gray, and red bars show a good same bad vote split, which is a simple tally of when the result looks better, similar, or worse than a competitor. The left block compares against Video Q2 in multi-keyframe mode, and the biggest gain shows up in prompt following. The middle block versus Pixverse versus 5 shows a strong overall advantage, while the right block versus Keeling 2.5 stays close but still edges ahead overall. Table 1 shows which training ingredient actually drives the human preference gains, using the good same bad score as a simple vote-based metric. The full table breaks results into visual quality, motion effects, prompt following, and overall. The first row says supervised fine-tuning mainly boosts motion effects while leaving visual quality unchanged. The next block shows tailored differentiable prompt optimization, improving abrupt cut handling, and also improving subject motion realism. The last row shows shared rotary position embeddings in super resolution, giving a large jump in preference because it reduces flicker and color shifts. Alright, 2 takeaways stand out. DreaMontage shows that arbitrary keyframes and short clips can guide a single continuous long take, as long as the model is trained to respect how video latents represent time. It also shows that preference optimization, plus a memory-efficient segment-wise autoregressive strategy, can improve motion realism and transitions at longer durations. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.